All right. So we're in that goofy week. And the week is goofy because we have class today. And that's it for this week, for Algebra 3. Okay? Because tomorrow you have class. Wednesday's Warrior Day in the morning, and conferences in the afternoon. So we see each other today, and then we'll see each other in a week. Okay? So I'm like, what can we do? What can we do? What can we do? And it just so happened, it timed it out perfectly that we're dealing with something that you've got a ton of experience with. It might not be your favoriteest experience ever, but it's a ton of experience with it, and that's factoring. Okay? And we're going to utilize factoring to get to next week solving equations. So I'm like, well, let's just take today and have it be factor day. Okay? So we're going to have factor day today. Okay? So we're going to factor, and today, then next week, Monday, we'll get a quick refresher on factoring. We'll add one more kind of factoring, and then we'll start solving next week, Monday, right away. And then utilizing that to solve the algebraically, do some upper level algebra type stuff, which is fun.
I like your pun.
Putting the fun in function.
Yeah.
Mm-hmm.
No.
Puns make me numb. Math puns make me number. Get it?
Oh, I do.
Get it? Puns make me numb. Right?
Okay.
Math puns make
Better
me
she can't see. Yeah, sorry, I forgot.
number.
Okay, yeah. Okay.
If you can't see, you should probably move forward here where there's plenty of
I
space
can
right up
see
front.
that.
Yeah,
I just didn't leave it.
Okay. All right. So let's refresh our memories on the 4 ways to factor, okay, that we know of. Really, we know 5, okay, but we don't count the 5 because it comes last. So, okay. So the very first thing that you should look at when you're factoring, and this happens every single time, you're going to do this one first, and then you're going to do number 2 second, and you're going to do number 3 third, and you're going to do number 4 fourth, and then you're going to get to number 5. And then if you can't do any of those, then we got to go a different way. Okay? Right? So the very first thing you're going to do on every factoring problem is you're going to check for a GCF, a greatest common factor. That's what GCF, greatest common factor. Okay? So if we're dealing with numbers, okay, we look for the biggest factor. And we factor that number out, and we divide that number out. If we're dealing with variables, first off, every term has to have it. And then we take the smallest exponent. Which might just be 1. So like if every term has an x, but one of them only has 1x, and that would be the x we take. Okay? So looking at 8x squared plus 20x, the first thing that I'm going to look at is I'm going to look at the numbers, 8 and 20. Is there a number that goes into both 8 and 20? Yes or no? Yeah. Okay. So now I got to find the biggest one that goes in there, because there are actually 2. Okay. So 4 is the biggest one that goes in there. So I'm going to pull out a 4. Okay. Then I'm going to look at this term has an x. This term has an x squared. That term has an x. So they both have an x. So this exponent here is 1, so I'm going to pull up just 1x. Now, that's going to leave me with something still in a set of parentheses. Okay? Well, 8 divided by 4 is 2, so then I'm left with 2x there. 20 divided by 4 is 5, so I'm left with plus 5 there. So the factored form of 8x squared plus 20x is 4x times the quantity 2x plus 5. Okay? So we're going to do that every single time. Next one that we're going to do after that, then we're going to look for if we have the difference of perfect squares. Okay? Now, there's one key word in there, and that is difference. Okay? It cannot be an addition in between the two perfect squares. That's the most common factoring mistake. It has to be a difference. So that means subtraction. So the first thing you look at is if you've got two terms, a binomial, if you've got a subtraction sign in between them. Okay? If that's the case, then you look at, see if you got perfect squares. Again, if you are dealing with numbers, the perfect square numbers, 1 to 100, are 1, 4, 9, 16, 25, 36, 49, 8 is 64, 9 is 81, 10 is 100, and so on and so forth. 121, 144, 169, 196. 14, 225 is 15, 256 is 16, 17 is 2, I want to say 89. There's somewhere in that range. Yep. And so on and so forth. If we're dealing with variables, a perfect square variable has an even exponent. If it's a perfect square minus a perfect square, then it factors into a minus b and a plus b. Nine x squared minus 1. 9 is on my list of perfect square numbers. X squared has an even exponent, so 9x squared is a perfect square. 1 is on my list of perfect square numbers, so this is like 3x quantity squared minus 1 squared. So this would factor then to be 3x minus 1 and 3x plus 1. Now, might you have to do GCF first before you can see that it's a difference of perfect squares? Yes. Okay. Might you have to do GCF first before you do the next one? Yes. Okay. Well, actually, I'll save that for. I'll save that for the second example. Okay. You have to, when it says factor completely, if you only partially factor, You are saying, I'm going on a trip to Milwaukee. I'm going to go down and I'm going to watch the Bucks play. Okay? And you pull into Fond du Lac and you say, hello, Milwaukee! And you're not there yet. You're on the way, okay, but you're not there yet. Next one is called the basic product of two binomials. Okay? And for lack of a better term, I call this one two parentheses. Really, that's not what I call it. I call it butt cheeks. Okay? Because the two parentheses is like their butt cheeks. Okay? Okay? So it's butt cheek factor. Okay? Now, how we do this? We take this first term. Okay? So these two first numbers here have to multiply together to be that one. Okay? Well, what multiplies together to be 2x squared?
2 and 1.
That only gets me 2.
2x and 1x.
There you go. That gets me 2x squared. Okay? Now, with the same enthusiasm, does it matter if I put x first or if I put 2x first?
Yes, it does.
It does? No, it doesn't. Yeah, it doesn't. No. Okay? Most people would put the 2x first and then the x. Okay? But you could be cray. Okay? Alright? Then we gotta take those two. So 20 we gotta break that up into two numbers that multiply together to be negative 20. Well, that's gonna be negative 1 and positive 10. Or excuse me, not positive 10. Come on, that's very better than that. Negative 1 and positive 20. Or it could be 1 and negative 20. It could be negative 2 and positive 10. Or it could be 2 and negative 10. It could be negative 4 and positive 5. Or it could be positive 4 and negative 5.
Negative 4 and positive 5.
You sure?
Yes. We'll do like the 5 first and then the negative 4.
No, does this one matter where we
Yes.
put them? Yes, this one matters where we put them. So you're saying I want to put the negative 4 here?
No. You want to put the 5 there?
Are you sure?
Yeah. Yeah, put the 5 there.
And then put the negative 4 here?
Yes.
Okay. Now, with this one comes we have to check it. Okay? And how we go about checking it is we have to take these two, let me erase these because those be gone now. Okay? We have to take these two numbers and we have to multiply them together, and that gets me positive 5x. Then I have to take these two numbers and I have to multiply them together, and that gets me negative 8x. When I add these two together, I should get this number, that term right there. And do we?
Yes.
Yes, we do. So this factors to be quantity 2x plus 5 times the quantity x minus 4. And the last one for today is the sum and difference of cubics. Okay? But I'm going to save that one for a later slide. We got a whole slide just for this one.
Like, you mean not today?
No, like in like 3 slides.
Oh. How many slides are there?
1, 2, 3, 4, 5.
What slide are we on right now?
2.
2. We're almost halfway there.
Mm-hmm. Okay. So when I tell you to factor, I am going to tell you to factor completely, which means that you need to factor until you can't factor anymore. Okay? All right? So again, following those steps, the first thing you're going to look for is you're going to look for a GCF. The second thing you're going to look for is then once you've GCF'd it, then okay, maybe it's a difference of perfect squares. Maybe it's a trinomial that can be factored. Maybe it's a crazy combination of a cubic plus or minus a cubic. Okay? What do you mean? Yeah. Yeah. Okay? So start a new page with this example.
You're not going to win.
I know. I get it. I understand. 100%. I'm married. I know. Okay? Alright? So, between 14 and 98, is there a common factor?
Yes.
What?
7.
7? 14? And 14 would be bigger than 7. So if we did 7, then you should have seen that they were both even at the end, and so we could have factored out another 2. Yep. Okay? So I'm left with, so if I yank out, can I factor out an x from both terms? No. So the only factor that I can factor out is 14. Okay? What's left over then? $98 divided by 14? 7, so that's going to be 7x. 14 divided by 14? 1, and then the minus sign stays the minus sign. So that would be, okay, so with me? Come on, you know better. Yeah, no, if you were sorry, you'd have it in your bag already and not be checking it every time I turn around. Okay? So now what I got to do if I'm factoring completely is now I've got to look at this part right here. And I got to say to myself, self, can that be factored more?
No.
Nope. Okay. So then that is my answer. 14 times the quantity 7x minus 1. Huh? B. Is there a number that I can factor out between 12, 22, and 8?
Yes.
What's that number? 2? Okay. Between the x's, can I factor out an x? How many x's? 1. Okay. So then what am I left over with? 6x squared plus 11x plus 4. Yes? Okay. Now I gotta look at that red piece and I gotta say, can that be factored? So let's try it. The 2 and the x are going to tag along. I think they're called the mora fish, right? Aren't those the fish that swim along with sharks and like eat the bacteria and the dead skin off the backs of sharks?
Yes.
Those are mora fish?
Yeah. What are the fish that like you would put your feet in it at certain spots?
Yeah. 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 But they're not swimming along with you as you're walking down the street. The Amora fish is swimming along with the shark and just, coming along for the ride. Okay? All right. So what multiplies together to be 6x squared?
2, 3, 1, 6.
Okay. So which one do you want to try first? 2 and 3. So do you care if you go 2x and 3x or 3x and 2x? Then that. Okay. What multiplies together to be 4? 1 and 4, 2 and 2. Which one do you want to try? 2 and 2? Okay. So if I try 2 and 2 then, both positives?
Just kidding.
Well, hey, it happens. Okay. So these middle two get me to 6x, right? These outer two get me to 4x, right? 6x plus 4x? 10x. Is that 11x?
No.
Nope, so we can't do it that way. Okay? What do you want to change?
1 and 4 instead of 2 and 2.
Okay, we'll try 1 and 4 instead of 2 and 2. What, you want to go 4 first or 1 first? 1 first, and then 4. So my inner two get me to 3. My outer two get me to 8. 3 plus 8 is
11.
11. Shabam. So this one factors to be 2x times the quantity 2x plus 1 times the quantity 3x plus 4. Yes, sir.
So I have the 3x plus 4, the 2x plus 1 flipped around.
That's fine. Yep. But you can't flip around,
You can't,
yeah. The terms can actually flip around, but yeah, the order, because multiplication doesn't matter, or order doesn't matter in multiplication. Yep. You try those two. Factor those two completely. Alright, so numbers wise, I can factor out a 5. Variables wise, I can factor out 3 g's. So that would be 5 times g cubed. And then that's going to leave me with g squared here and 16 there. Okay? G squared plus 16, can I factor it? Yes?
No.
Why not?
G squared plus 16.
Yeah.
Because there's no 16 in G squared and there's no G squared in 16.
It's not a difference of perfect squares. They're both perfect squares, but it's not a difference.
Yeah.
Okay. Numbers. Anything go into 75, 30, and 3? 3. Variables wise, I can factor out an x.
You already wrote it.
75x cubed divided by 3x would be 25x squared.
Yeah.
30x squared plus divided by 3x is going to be 10x. 3x divided by 3x is 1. Okay. Let's try 5x and 5x. 1 and 1. Those add together to be 10x. So we're good there. This 3x comes along for the ride. So my final answer here then would be 3x times the quantity 5x plus 1 times the quantity 5x plus 1, or because they're both the same, we could write this as 3x times the quantity 5x plus 1 squared.
So would you prefer that, like, is that simplest form right there, or does it really matter what one?
They're both fine. Okay? Alright, let's get into cubes. So, those are the patterns. Okay? Let me move those over just a little bit. So if we're dealing with a sum or a difference of perfect cubes, then they can be factored. So in terms of numbers, my perfect cube numbers are 1, 8, 27, that's 3, 4 is 64, 5 is 125, 6 is 216, 7 is 343. 8 is 512. 9 is 729. 10 is 1,000. Okay. In terms of variables, the exponent is a multiple of 3. That makes it a perfect cube exponent. Okay? Now, do I full on expect you to memorize these two formulas? No. Okay? I don't have it memorized. I memorized the pattern. Okay? The pattern is this. So you first have to look at that sign right there. Okay? Because then this one follows that sign. And we just write it as uncubed, uncubed. Okay? So that follows that sign. This one is opposite. This one is always plus. Okay? Squared product squared. You square the first one, product of the first and the last one, square the last. Alright? Alright, let's put it to work. Is 27 a perfect cube? Yes. Is 125 a perfect cube? Yes. So my numbers are cubed. Is x cubed a perfect cube?
Yes.
Yeah, because it's a multiple of 3. So I have a perfect cube plus a perfect cube. First, do I have any greatest common factors?
3.
Does 3 go into 125? 1
Yes.
plus 1
Yes.
plus, listen. 1 plus 2 is,
3.
plus 5 is
8.
8 divisible by 3. Then 3 doesn't go into 125. Okay? You add up the digits, And if the sum of the digits is divisible by 3, the number is divisible by 3.
Oh.
1
like
plus 2,
125. Okay, yes.
1 plus 2 plus 5 is 8. 8's not divisible by 3, so 125 isn't divisible
Does
by 3.
that work all the
2
time?
plus 7 is 9.
Would I tell you if it did? What?
Oh my gosh. 2 plus 7 is 9. And,
Oh, the 27. I'm like, where? Yeah, 2 plus 7 is
yeah.
9, so 27 is divisible by 3, yes.
okay, what about,
125.
Okay? So any greatest common factors? No. Okay? Right? So this then really is 3x quantity cubed plus 5 quantity cubed.
is that how we can how do we-
Well, because 3 times 3 times 3 is 27, right?
Oh.
And x times x times x is x cubed. And 5 times 5 times 5 is 125. Right?
Right.
Okay? So this is going to be 3x and 5, and I'm going to add them.
So what happened?
Then I'm going to take 3x and I'm going to square it. Then I'm going to take 3x and I'm going to multiply it times 5, but the sign there is going to be opposite. Since it's plus there, it's minus there. Then I'm going to take 5 and I'm going to square it. What do you mean, write that whole thing up?
On like tests and stuff, we have to write them all out.
Do you want to show your work?
Is that like showing our work?
Am I done yet?
I don't know.
Well, am I done yet?
I don't know.
Have I stopped talking yet?
I don't know.
No, I haven't.
Okay.
Right? So my final answer then would be 3x plus 5 times the quantity 9x squared minus 15x plus 25. The cool part about it is the trinomial, just if you guys would honestly pay attention and wait for me to finish, all of your questions would be answered. Okay? Right? The nice thing is that the trinomial that you get there is not factorable. Okay? This trinomial that you get at the end is not factorable. So once you apply the difference of cubes, you're done with that one. With that trinomial, you have to go check it in. Right.
On the test, so like 3 questions.
I'm not worried about the test. Nor should you. Okay? You should just show all the work that you should show. Right? Good? Okay? Now, the next thing that we need to talk about is the fact that the end of the quarter is Wednesday. Okay? On the quarter grade, which quarter grades, remember, are kind of important. They determine athletic and activity eligibility. They determine commons privileges. They determine off-campus privileges. All that stuff gets determined by your quarter grade. Okay? So this quarter so far, we've had 7 homework assignments. We've had 2 formative assessments, 2 summative quizzes, one of which I still have to correct. I didn't get them all corrected this weekend, so I'm not handing them back today, and 2 summative tests. Some of you are missing multiple of these 13 things. Okay? you have until tomorrow at 3:00, because Wednesday the MRC is not open because it's Warrior Day in the morning, and then it's conferences in the afternoon. So you have until 3:00 tomorrow to get all 13 of those things to where you want it to be. Okay? All right? Because today is the only day of the week, no homework. Okay? Or no homework this week. Okay? All right? That's all I got for you.